So into the output characteristics of the CE configuration. As mentioned earlier, we'll be using the same diagram, same circuit diagram for the output characteristics of CE configuration as well. But the difference is here we'll be measuring the output characteristics, that is the VC and IC. The graph what we'll plot will be with respect to VC and IC. In input characteristics, we plotted the graph, or the graph whatever we have seen is with respect to the VBE and IB. Here it will be with respect to VC and IC. So from the same diagram mentioned earlier, we know that VCE equals to VCB plus VBE, and it's just the same hypothesis. Whatever the condition, whatever we have taken for the input characteristics is just same as here as well. So what happens is, as VCE increases, VCB also increases. For VBE, we'll keep VBE as constant, and we know that if VCE is increased, VCB will also increase. Thus it also increases IC. As VCE increases, if VCE is increasing, that is the potential difference between the collector and emitter junction is increasing, means the flow of charges from the emitter and the collector region will also increase, right? And if IC increases, the collector current is also increased as VC. That's what it says. And if we apply some small current, or IB, call IB, IB is the base current. If we apply even small current to the circuit, the IC will increase by a factor of beta. We know what beta means. Beta means amplification factor, which we saw in the working of BJT, and we know the formula, that is the relation between the current, collector current, and the base current, that is IC equals to beta IB. And the amplification factor here, hence we can derive that beta DC, that is amplification factor with respect to DC voltage, is given by IC by IB, and for alternating current it is given by beta AC equals to delta IC by delta IB. That's it. So this is about the BJT working in the active region. This is only for the BJT working in the active region. We'll see the graph for this in few minutes, and we'll check out the, before that we'll be checking out the different regions as well. For saturation region, see, for BJT to be working in the, or in a saturation region, as VCE, that is the potential difference across collector and emitter junction, is tending to 0, the VCB, that is the collector and base junction, and the base and emitter junction will be forward biased. Okay, and if it is forward biased, what happens is we will see a constant growth. Okay, we will see a constant growth in the current, and at one point it becomes constant, like there will be an increase in the current, and at one point it becomes a constant value. Okay, that is the IC value, right? So what happens is, summarizing it, VCB and VBE will be forward biased when VCE becomes 0. Okay, and not really 0, it tends to 0. What happens in that case is, VCB and VBE will be forward biased, and the current will slowly increase, and at one point it becomes constant, that is until the point where VC is reverse bias, that is until the point where the BJT in the CE configuration will form a reverse bias condition for common, that is common emitter configuration, or collect potential across collector and emitter region. Okay, this is about saturation region. For cutoff region, the base emitter voltage, that is VBE, is 0. Okay, even if the VBE is 0, we will see a small amount of current which is being flown, or which will be measured in the output terminal. This is due to the small current which we observe, that is called as leakage current. Okay, and this small current, so we can conclude by saying that BJT is never gonna give a zero output, something like that. It will always give even the smallest value for current as well. So BJT never really becomes a zero. That is what the cutoff region or the values which we will be observing in the graph as well. Here here you can see the graph for the output characteristics of the BJT. And as you can see, as mentioned earlier, consider the saturation region. As I said, as VCE tends to 0, here you can see as at the region 0, almost close to the 0, we can see a small, I mean the constant growth of current, right? There is a constant growth of current, and at one point, at certain point of VCE, we see the graph going like a, it becomes, the value becomes constant, and it does not really increase rapidly, or it does not become totally constant. It will slightly keep on increasing. So here you observe the saturation region. That is, saturation region, we will be seeing the small constant growth of current until the VCE is reverse biased. That is what saturation region represents here. And for the cutoff region, as mentioned earlier, here you can see a small amount of current which is being measured in this region. That is the cutoff region. This is due to the concept of leakage current, what was mentioned earlier. Okay. And coming towards the active region, as mentioned earlier, the IC, as IC keeps on increasing, as VCE keeps on increasing, IC also keeps on increasing. You can look at here that as VCE increases in the x-axis, even IC is also increasing in the y-axis. So this is all about the output characteristics of the CE configuration.